op-amps, whether they're ideal or not, give us a good way of thinking about amplifiers in general. They really are no different than any other basic amplifier. They're a difference amplifier, of course. They amplify the difference between the input and the output so that we have V out is equal to V2 minus V1 times the gain A. And if we, this would be the sort of the typical beginning way to think about it, but thinking about it as the split power supply, or signal source, I should say, over here, has some real advantages as well. And if we think about that, where we have VICM, input common mode voltage, and a differential voltage, then the gain is VID times, sorry, the output is a VID times A. Oops. These are totally, absolutely identical ways of thinking about how we would arrange the input signal sources. There's really no difference between them at all, and it's straightforward to convert between them. So we can look over here and just say that VID is equal to V2 minus V1, and so in that, with that statement, then the statement here that V2 minus V1 times gain is really the same as VID times gain. I'll change that. I'll put the order in the same there. So oops. There we go. VID times the gain A. And VICM, the input common mode voltage, is the average of the two input voltage sources. You could think of this split arrangement as more abstract, but actually it's probably more concrete and more normal than the way of thinking that we have two separate power supplies. It's very, very common to have a DC bias voltage and a signal on top of it. That's just how we do most of these things. So it's really very normal. It's just maybe perhaps more intuitive to understand it by the two input supply method. So V1, we could translate into that other system as VICM minus VID over 2, and V2 is equal to VICM, that average voltage, the bias voltage, or the common mode voltage, as VICM plus VID over 2. VID is half the differential voltage, half the input differential voltage, so we could add or subtract it to get our gain, or our signals. So we could use some real numbers here. So let me slide this up a little bit more. So if we have a gain of 5,000, let me go back to black here. If we have a gain of 5,000, so that's a real op-amp now, and we have some values of V1 on the input, and V2, VID, VICM, and V out. Of course, these are really sort of consistent, or if we know one, we know the others, of course, or if we know a couple of them, we know the others, depending on which one we know. So if we had V1 is 1.002 volts, that's 2 millivolts, with a 1 volt bias on it, and, or I should say, a 0.998 volts on V2. So what would be our differential input voltage. So that's this one right here. What would VID be? Well, it's V2 minus V1. So V2 is 0.998, or 1 minus 2 millivolts, you could look at it. And V1 is 2 millivolts above that average. And we would get an input differential voltage of minus 4 millivolts, right? There's 4 millivolts difference between these two voltages. And we need a negative sign because V2 is smaller than V1. And we find VID is V2 minus V1. The average of these is just 1 volt, right? And the output voltage would be VID times the gain of 5,000. VID times the gain of 5,000. And that works out to minus 20. Oops, what I wrote? V out there. V out is minus 20. So we had a difference of 5,000 volt, or a amplitude, a gain of 5,000 volts per volt. And in one case, we could find that we've got a gain, input differential voltage of 4 millivolts, and 5,000 times that gives us an output of 20 volts. Now, if we had an input of 0 volts on V1, and V2 was 1 millivolt, now we have VID is 1 millivolt, right? Because it's VID is V2 minus V1, 1 millivolt minus V1, which is 0 volts. And VICM now would be 0.5 millivolts, the average of these two. And the output would be 5 volts. 1 millivolt times 5,000. Now, if we were given VID as 0.5 volts, or 0.5 millivolts, so the differential voltage between those two, and VICM is 2 volts. Well, what is V1? Well, we can get V1 is VICM minus VID over 2. VID is 0.5 millivolts. So half of that, that's going to give us V1 is 1.9975 volts. And V2 is that average, VICM, 2 volts, plus that, so 2.0025 volts. And knowing VID, we just multiply by 5,000 to get a gain of, or an output of 2.5 volts. I hope it's not too much for you that I'm not going through all these equations. You can see the equations and you can work them out, and I'll see if I can create some practice problems for those. If we're given VICM is 2 volts and the output is 8 volts, right? Well, on the basis of that, we would know, we don't know VID yet, but we know this equation, we know V out and we know A, so we can find VID. And VID then must be 1.6 millivolts. And once we have VID and VICM, we've got V1 is minus 2.0008 and V2 is minus 1.992. One more 9. So hopefully I've got those right. You can try them yourselves. They should come out about right. So I'll see if I can't create some problems for you to work on right there, but then I've got some more examples. So come right back here, and after you finish those examples, it should start up again. So we could also write some of these numbers. Well, let's see now. I should write down the equations again. So we've got V out let's change color. V out is equal to V2 minus V1 times A, and that equals VID times A. VID is equal to V2 minus V1, and VICM, the input common mode voltage, is the average of V2 and V1, V2 plus V1 divided by 2. And we have V1 is equal to VICM minus VID over 2. And V2 is equal to VICM plus VID over 2. And with that, we could figure a few values here. So if we've got V1, V2, VID, VICM, again, the ideal, V out, and the if we have VDD equals plus minus 15 volts, V out. So we could have some possibilities there. So if we had an input, let's see, if we've got a gain, an infinite gain, that was a lousy infinite. If we've got infinite gain, and we've got V1 is 0 volts, and V2 is 0 volts, and VID is 0 volts, then VICM, the average of 0 and 0 is 0. And the ideal output is 0, and the actual output is going to be 0. So that's reasonable. If we had 0 and 1 millivolt on both, well, on V2, I should say, not on V1, but on V2, then VICM must be half a millivolt. Still have infinite gain, go through that for a few times. The ideal output now will be infinity, because it will be positive infinity. The V2 is larger than V1. We have a differential voltage. But if we had a real op-amp, we'd have a maximum of plus 15 volts. Why is it plus? Well, the ideal output would be plus infinity. So it must be that if we're limited, then we're limited to 15 volts by that real power supply limit. Still, if we have infinite gain, but now we've got an input of 0.001 millivolt in V1 and 0 on V2. Now we've got a negative differential, and things are gonna look pretty much the same VICM, but now our gain is going to be infinite, a negative infinity. That's the best we can get, and our output would saturate. If we had power supplies of 15 volts, it would saturate at 15 volts. Probably a little bit less than that, but something kind of like that. If we have a gain of 1,000, and we have 0.001 and 0 and minus 0.001 for VID. VICM is still 0.005, half a millivolt. But our gain is now, our actual gain is no longer infinity, it's 1,000. That means we would have a actual output of minus 1 volt. And with this real unit, with this real power supply limit, we would also have an output of 1 volt. it'd be exactly the same because we have not exceeded this limit here of plus or minus 15 volts. If we had an input of 0 and 0.001, and we had VID then of 0.001, 1 millivolt, and VICM is, again, half a millivolt, and we have a gain of 1 e to the 6. Our output, our ideal output would be 1,000 volts, right? But actually we would get 15 volts output on a real op-amp because that's our limit given to us by those power supplies. We could go I could put plenty more numbers in it, so I'll give you some practice and let you try, but you can use these equations to work back and forth between whatever supply you're given, whatever information you're given. As long as you've got 2 or 3 of these items, you can work out everything else.